All right, so this is getting to be a little closer where we're going to involve calculus, although we still don't really need calculus yet besides the idea of limits for this infinite series. But what we're going to look at here is the interval of convergence of a geometric series. And what that means is we're going to look at a formula in sigma notation, and we're going to decide what values can we plug in for a particular variable so that it will converge. And so just for the general geometric series, if we have a geometric series, we know that it's going to converge if the ratio is what? Less than 1, or between -1 and +1, right? So let's just look at an example here. This is an example of a geometric series. And in this geometric series, we have an extra variable in here. We've got this x. And so first of all, let's look at why this is a geometric series. Let's just plug some numbers in and get the first few terms of this and see what's happening. So what's the first term going to be if we put 1 in for k? Two-thirds times x plus 6. Okay, what's the second term going to be? 4/9 x plus 6 squared. Plus, let's get one more. Okay, so who can explain to me why this is a geometric series? So to go from one term to the next, you multiply by 2/3 times x plus 6. So to go from 2/3 times x plus 6 to 4/9 times x plus 6 squared, you multiply by 2/3 times x plus 6. Another way to look at this would be to rewrite this sum like this. Does that mean the same thing? Yeah, so every time I increase k by 1, I'm multiplying by 2/3 times x plus 6 one more time. So my common ratio here is 2/3 times x plus 6. You guys agree with that? Does that make sense? So the first thing we want to do when we want to figure out what the interval of convergence is to figure out what that common ratio is. Now, we know that the common ratio, the absolute value of the common ratio needs to be less than 1. Okay, so another way of saying that would be that it's between -1 and +1, right? So how could I figure out what x values would work here so that the common ratio in this problem is between -1 and +1? I could put this expression right here in for r and solve the inequality. And sometimes that's going to be a fairly easy thing to do. Sometimes it may involve a little bit more trickery. This one will be pretty straightforward. So we have -1 is less than 2/3 times the quantity x plus 6, and that's going to be less than +1. So if we want to figure out what values x can take on, we solve this inequality. I would start by multiplying all three parts by 3/2. Since I'm multiplying by a positive number, then I don't need to worry about what? Yeah, I don't need to worry about the direction of the inequalities. They're going to stay the same. So we get -3/2 is less than x plus 6, and that's less than +3/2. And then what else do I need to do? Subtract 6. So if I subtract 6, that's the same thing as subtracting 12/2. So we get -15/2 is less than x is less than -9/2. And this right here is what's called the interval of convergence. As long as x is anywhere between -15/2 and -9/2, then I know that I know that this series is going to converge. Now, it could not equal negative 15 halves, because if x was equal to negative 15 halves, then our common ratio would be negative 1. It could not equal negative 9 halves, because then our common ratio would be positive 1. But anywhere in between is going to give us a geometric series that's going to converge. Does that make sense?